So good afternoon, everyone, and welcome to yet another Copy with Curiosity here at the Planetarium. I'm Rajesh Gopakumar on behalf of ICTS, the International Center for Theoretical Sciences, TIFR. I'd like to welcome you. This Copy with Curiosity, as you know, is something we have been doing with the Planetarium for the last almost 3 years. October is when we'll be reaching our third anniversary. I think it's been a very wonderful collaboration, and we have been bringing every month to, I think, Bangalore, very stimulating experience of talk with renowned scientists. And this is part of one of ICTS's key mandates to have a vigorous science outreach. In addition to our other mandates of research in theoretical physics, mathematics, and related disciplines. But we also, about ICTS, perhaps for those of you who are here for the first time, ICTS also organizes a large number of programs and discussion meetings throughout the year. We had about 30 programs with about 2,000 visitors coming through. And in fact, as you may have, for those of you who have come before, you know that many of our program visitors are here as speakers at the Copy with Curiosity. ICTS is located in the northwest part of Bangalore in Hesarghatta. And we are having actually a public lecture also at ICTS campus in the coming week by Professor Abhay Ashtekar on various aspects of the Big Bang and gravitational waves and so on. So I would encourage those of you who are interested to come and participate in that public lecture as well. I will ask Professor Bala Iyer to introduce the speaker, but I must say on my behalf, I am really delighted that Professor Narlikar could come here for this event, and in fact also staying on at ICTS for a few more days for one of the programs that we are having. On my behalf, I just want to share one personal reminiscence. I still remember very vividly in my mind's eye when I was in class 10 or 11 was when on Doordarshan they screened Carl Sagan's Cosmos, and Professor Narlikar would be introducing each episode on Sunday morning. It was actually the second time I was seeing Carl Sagan's Cosmos. The Planetarium in Kolkata, where I grew up, had actually screened Cosmos, I think about a year before. And it had, of course, made a very deep impact on me, and it was delightful, and I would again wait every Sunday morning for the Cosmos episodes. And I think Carl Sagan himself was very eloquently spoke about, not only about science, the wonder of science and the discoveries of science, but also the culture of science. And so it's particularly, I think, very fitting that we have Professor Narlikar here today to tell us about the culture of science, something we need to keep reminding ourselves, keep reaffirming our faith in it, as the Constitution of India enjoins us to do, cultivate a scientific temper. So I'm looking forward to hearing Professor Narlikar on that. But before that, let me invite Professor Bala Iyer from ICTS to give an introduction to the speaker.
So on behalf of ICTS, Jawaharlal Nehru Planetarium, and the Copy with Curiosity, I'm delighted to welcome Professor Narlikar to this special session of the Copy with Curiosity. Jayant, of course, requires no introduction, but to the young people in the audience, I just want to talk about a few highlights. Jayant Narlikar is currently the Emeritus Professor at IUCAA, an institution that he founded in 1988 and was director of till 2003. IUCAA has acquired a worldwide reputation as a center of excellence in teaching and research in astronomy and astrophysics. It is involved in mega projects like the 30-meter telescope and LIGO India and the ISRO project AstroSat. Earlier, during 72 to 89, he was head of the theoretical astrophysics group at TIFR. As Rajesh mentioned, all of us have childhood memories about Jayant, and I am always impressed by Jayant's ability to start a lecture on fairly profound, subtle, and technical themes like action at a distance in physics and cosmology or Marx's principle from very elementary basic discussion. In every lecture of his that I have heard, he covers a fair amount of ground, starting from the very beginning and leading on to what he is currently researching on. He reminds me of a capable, composed, and competent guide taking a group of motley tourists up a mountain, leading everyone to the heights their capability can reach. Everyone gets a view, maybe a different glimpse, but everyone is happy to have participated in the trek and the adventure the Jayant leads them on. No wonder he is a popularizer par excellence and holds a record for such lectures, writings, and films that would be difficult to match. I personally also sort of remember that my final research into general relativity was probably triggered by an article he wrote in Science Today, which was called The Arrow of Time. So, there are many people who, from their childhood, would see subconscious influence of Jayant on their careers. Professor Narlikar was awarded the Padma Bhushan in 1965 when he was just 26, the Padma Vibhushan in 2004, and the Maharashtra Bhushan in 2011. For his contributions to science popularization, Professor Narlikar was awarded the Indira Gandhi Prize by the Indian National Science Academy in 1990 and the Kalinga Prize by UNESCO in 1996. His talks, thank you. His talks not only convey the excitement of astronomy, but also the importance of the scientific outlook. The lack of scientific outlook, in his opinion, has been a hurdle in the progress of the country towards a better and more enlightened way of living. He has been emphasizing this in his various talks, almost with a missionary zeal, and has found several ways and means of popularizing the scientific outlook and rational behavior. For example, many of you must have heard that if you wanted his autograph, you needed to send him a postcard with a scientific question to which he replied with his signature. Narendra Dabholkar was one of the foremost proponents of scientific temper in recent times. Through his lectures and writings, he spread the message of scientific temper among all sections of the society. Many, including Jayant, felt it is particularly appropriate that 20th August, the day on which Dabholkar was martyred, be observed as a National Scientific Temper Day all over the country. KAAPI with Curiosity agrees, and this is what prompted us to invite Professor Narlikar to share with us his views on the culture of science. So without much further ado, let me hand you over to Professor Jayant Narlikar. Jayant.
Oh, thank you. Friends, it is indeed an honor to be invited to speak in your distinguished lecture series. So I chose a topic which people normally don't think of in terms of usual work. Now, one could ask how science, which is considered neutral and objective, how such a subject may have a culture of its own. How do you define it? And again, you can ask, how do practitioners of science, that means scientists, users and creators of science, how do they view their subject at any given time? Similarly, one can ask, what has been the attitude of the society towards science as a driving force? So these are various issues which keep coming to one's mind. And in this context, I am reminded of Professor D.P. Chattopadhyay's statement, which I will quote. In a philosophical vein, it has been said that civilization is what we do possess or have, and culture is what we are. So interpret the statement as follows, that one could say that the technology used by a society is part of its civilization, while the spirit which motivates its science is part of its culture. Issues that come up in this context are various, such as nuclear weapons, should one develop them further and further, or one could ask cloning and other experiments that interfere with natural production. So all these questions come, and how one reacts to them, how one compares its effect with other effects. All these can be part of culture of science. Now, I want to give you some examples in this context. Some of you must have heard of the Crab Nebula supernova. And of course, in this particular building, it would be presumptuous on my part to assume that you don't know it. So I'll just say that I will use it as an example, and you will appreciate for what purpose. So as you know, the history of this is the old records of the Chinese astronomers where on July 4, 1054, they recorded the seeing of something which is a very bright star in the sky. And it was so bright that even in daylight, one could see part of it, and at least for the first few days. And it remained in the sky for some time, for a few weeks, few months maybe, depending on your observing capacity, and then disappeared. So because it came for a short while in the sky, the Chinese called it guest star. Guest comes and goes. So the question was, just as the Chinese saw it, did any other culture, any other civilization make a note of it? So the two examples that we have, in addition to the Chinese, one was the event was recorded by Red Indian tribes in the form of rock etchings and drawings on the wall. They saw something which they tried to express, not in words, because presumably they did not have the ability to write words. So, but it was in terms of what they saw. So they tried to picture it. And the second example was that of Ibn Bhutan, a physician from Middle East. He was working on an idea that celestial events might cause illnesses on Earth on a large scale. So he was trying to compare the epidemics which come and go, came and went, and he wanted to compare their record with what stars were like in the sky, and was there anything special about them. And in this process of keeping a record of the stellar environment, he must have noticed this particular phenomenon of sudden brightening of a star. So this was the information that we have. The question, several questions do arise. when you look at this example, why no records of this are found in European writings, because it was visible from there also. It was not that it could not be seen. And the second was, what about India? Why have we not found any records from India? You could say, for example, by way of defense, that July 4th would be in the monsoon period. So in the cloudy sky, you cannot see this. But this was an event which was not a flash, seen and went kind of thing. It was there for some time. It had certain degree of permanence or semi-permanence about it. So why didn't we find anything in Indian writings? So in this context, myself and Sanskrit professor at Pune University, Saroja Bhate, at that time, we undertook a study of some old manuscripts belonging to a period relevant to this 1054 AD. That is, it should be after that, because if they recorded something, they should be, that event should have happened before. So the question was, are there any things in the manuscripts? Now what we did, of course, was to look at old Sanskrit manuscripts. And we did I thought a fairly systematic bit of work with a number of volunteers from Professor Bhate, who supplied us with readers for these manuscripts. So a large number of manuscripts from different libraries were looked at, and we couldn't find what we could consider, in a sense, relevant material. So it rested there, but then there was also the work done by Shailaja here, which does show some positive indications that this kind of thing was seen, this event was seen by Indians. So I would take the liberty of reading out a bit of writing that she has given of her work. So it says, right, the tradition of penning the facts as stones is widely spread all over South Asia. This was to say that instead of writing on manuscript, you put it on the stone itself, so it remains more permanent. So the language in the first millennium has been Sanskrit, rendering it easy to decode the meanings. An inscription in Cambodia, in the Pune province, describes the installation of Shivalinga by an ascetic. Half of the contents of inscriptions are devoted to the praise of Lord Shiva. The inscription is dated 1054 AD, based on the names of Samvatsara by historian R.C. Majumdar. On the adjectives, one of the adjectives used for the god is Shukratara Prabhavaya, which translates into as one who can create or influence a star to be as bright as Venus. Shukratara is a Venus. So, thus it is describing a star as bright as Venus and use it for praising the god. The supernova was bright enough to get here as a metaphor. The second half of the inscription is in the language Khmer, that is in that particular part of Cambodia. And again, the same adjective is used for the god. So she writes further, but I wanted to give you an example of something that is indicative that people must have seen this particular effect. So I will continue further. There was also a situation that people, why didn't people in Europe record anything? Because manuscript writing was fairly common in Europe. So George Sarton, historian of science and astrophysicist Fred Hoyle, independently argued that the event did not fit into the Christian belief that the world was created in 7 days. If the world was created in 7 days, how come a new star has come afterwards and is not part of that creation? So one could say, if you can't explain a particular event within your own frame of mind, frame of belief, then ignore the event altogether. That is the best choice. So that must have been the reason, according to these two distinguished scientists or literary persons. And a modern example of this particular behavior I will come back to later, where you tend to ignore what you don't like to see. So let me continue further. I will go now to another aspect of this question in terms of Galileo's work. Now, Galileo is believed to have, he believed in experimental science. If you are making some statement which is theoretical, he would not have been happy with just that theoretical part. He would like to know how to demonstrate that particular claim that you have made in terms of an experiment. So when he made a telescope, that produced a number of events which were earlier not seen because of our eyes not being capable of seeing it. But like 4 satellites of Jupiter, this is an example that could not be seen earlier. So the question was, how did he? Galileo, when he found 4 satellites of Jupiter, it meant there was something going around Jupiter. And this was not liked by the conventional intelligentsia because it meant that there are other things around which things can go round. The belief had been that it is the earth which is fixed and everything else goes around the earth. So in terms of this, this finding of Galileo was not fitting in. So people said that whatever you see through this particular contraption, namely the telescope, is not really what you see through the eyes. So there is some, what we would use in our word Mayajal, something which is not real, genuine, which appears when you use this particular instrument. So Galileo's book, he wrote a book on various experiments, and he had 3 characters in it, as those of you who may have studied Galileo would know. So the question was, one character was a conventional person who'd only believe what was given in the holy scriptures. The second one was somebody who was willing to accept whatever is experimentally given. And third was somebody who could draw conclusion saying that the real science is saying this and not that. Now when this was done, these 3 characters talked to each other, and although the book showed that the pro-convention had the last word, it was not actually, when you read through the argument, you would find that it was really the other guy who was scientific in his approach and asked the right questions. He really understood what was going on. So this was the way Galileo projected. Why did he put it in this particular way? The reason was, otherwise people would have been very angry to show that the guy who supported conventional thinking was wrong if he had done this. So even though he wrote this particular book in that particular fashion, he had problems. And as you know, the conventional attitude by the religious authority was to have a kind of equivalent of court case, although it was more one-sided than our courts. That court case was in which Galileo ultimately is supposed to have said, he of course said that I agree that whatever I said was wrong and what you are saying is right, to the religious authority, because he was told that unless he makes this kind of confession, you will be subject to a lot of torture and various kinds of problems will come for you. So he decided to say this, but having said this, he is supposed to have muttered to himself, but it moves, meaning that the earth moves. Although he said that the major effect was earth was fixed and everything was moving around it. So this was what Galileo is supposed to have done. Now, after this thing had happened, and as you know, this had happened in 17th century. A lot of time elapsed, and in the 1980s, there was a reopening of the case against Galileo by the Pope at that time. That is, in the 1980s, in modern times. So, what the Pope did was he appointed a commission to look at Galileo's, all the details of questions asked to Galileo and what he replied were recorded. So these records were there, and this commission was supposed to say whether Galileo was mistreated, wrongly treated or not. So this particular re-examination exonerated Galileo. he was, according to the commission, he was right in what he had been saying, and he was unnecessarily sort of subjected to all this pressure. So this was agreed, and the whatever they call equivalent to a delayed pardon was given for what help it did to him, but because he was no longer alive. Then, but this commission had also said that Galileo did not have the correct answer when he was asked by the Inquisition, that is the judge and the commission which was examining him in his lifetime. He was asked to give a proof why the earth moves and not and earth is not fixed, but it moves. How do you know? Now, as you know, Galileo had to give some answer to this question, and the answer he gave turned out to be wrong. And at that time, nobody around knew that Galileo's answer was wrong. What did he give, the answer? The answer was like that: if I take this glass full of water and walk, the water will spill out. Even if I walk slowly, it might slip out. So he said, look at the tides in the sea. The tides in the sea shows water coming out, going beyond the borders of the sea, but falls off. So that is the effect, because the earth which is carrying the oceans is moving. And this is the proof that the earth moves. Now, this was explaining the thing in a apparently scientific fashion, but the scientific explanation was wrong. And the real effect was the tidal motion, tidal effect, which required to know the law of gravity. But Galileo came before Newton, and the law of gravitation was still to be discovered. And therefore, the answer that Galileo gave was wrong. But the Inquisition did not know, of course. And it did more importantly, it did not care. It had asked this question because they felt that nobody should say, you didn't ask him, you give him the chance to speak. So they had done it. So whatever reply he had given, it was noted, but the Inquisition did not change its view based on what Galileo had said. So this is an example, again, of how somebody who is making very extraordinary statements, how is he treated in a society by intellectuals in that particular society. So one can go further in this respect, and I will give you some examples in Indian background. So the oral tradition in India did not give incentive to written accounts or to new evidence which could be preserved. So this is an example that we did not in our history pay much attention to written information, written knowledge. The idea was that if you are taking this knowledge from Vedas, then those Vedic pearls of wisdom have to be conveyed orally and not written down. So this was done, and for this reason, we also lost many important items of information. For example, it is said that Aryabhat, he had written a second book. That book has been referred to but is not known that such a book, what did it contain. But his own first book is known, and it is Aryabhatiyam. You find it well defined. And he makes the statement there that the earth spins about an axis rather than the idea that the earth is fixed and the cosmos goes around it. So this was a correct statement he made, but again, we have no record as to how he was treated. There are some indications, but I did not find them as credible as other historical documents, that he was treated as what you call somebody making a crazy remark. So later you find, Brahmagupta's time, he makes some very derogatory statements about Aryabhat. Although he praises him elsewhere, but in some places he says that about Aryabhat, he knows nothing. So I won't even describe what he wanted to do and what he wanted to say. It was a very strong thing to say from Brahmagupta to Aryabhat. So this problem again shows that people were very much conscious of what was written, what was orally said as the important evidence and not something that is written. Now there is a tale or episode in Adi Shankara's life, Shankaracharya, the first one, in which he went all over India arguing Vedic and other knowledges with opponents who did not believe in them. His idea was to have logical discussions and to show that using the proper logic, you are having a proper answer to various questions rather than your enemy has or your opponent has. So he was told that he should go for this kind of thing. If he is going for this religious arguments, he should go to Mandan Mishra. Mandan Mishra was a very distinguished person, and he was against the kind of philosophy that Adi Shankara was spreading out. So it was necessary for Shankaracharya to go and argue with Mandan Mishra. So the story says that when he went in search of Mandan Mishra's house in the city in which he lived, at one place he found that there were maid servants washing clothes in a ghat-like thing, where you got a lot of water, kunds there. So in such places, people used to go and wash things. So these ladies were washing there, and he asked them, where is Mandan Mishra's house? So one of the ladies replied, and the fact that she replied in this fashion is indicator that even local neighborhood was well versed in various kind of philosophies. So what she said is that if you go to a house in which there are birds in a what you call cage, closed cage, hanging at the entrance. And these birds are arguing with each other whether the universe was infinitely old or whether it was of transient period. So see, modern cosmology hasn't progressed much, has it? So they were, so go to that particular house. Now we asked, and apparently he did that. He found those birds arguing about the universe, the origin of the universe, and transience or permanence of the universe. And when this was done, he was Shankaracharya went there and had a fairly extensive argument, and ultimately he won. That is also another story, that he won against the husband, and the wife said, you have to defeat me also, in the thing. And because only the two of us will make one whole. Ardhangini is called. So he had to appear in argument against her also. And she started asking him questions which were not known to, the answers were not known to the bachelors. And he said, at the moment I don't know, but I will go and find out and come back. So anyway, that's a different story. So the second point that I want to make is that we have a kind of attitude towards older records, which is not very critical. So I found one very interesting example in which I was myself fooled by the example, and this is about a book called Shukraniti. This is about 2 or 3 centuries old. That is about 1600 years old. And in the Shukraniti, there was a chapter or a series of shlokas in which it gives you the rules of human relations. How, for example, if you are employing somebody, that person, whatever you pay him, you must allow some money for future. When that man retires, he will need some money. So that can be used, that particular store. So it's a pension fund. And it said, it prescribed something like 1/8 of the salary. So that looked very similar to what modern ideas are. And various other things where these ratios were specified. So I wrote in an article in Times of India saying that our ancients, if they wanted to be very precise, they could give some ratios and numbers like in Shukraniti. So that shows that they could write something very precise or scientifically credible. So when I wrote this particular article, afterwards I got a letter from some Pandits in Banaras, in BHU, Banaras Hindu University, my old alma mater. These Pandit wrote that what you have given as an example is not correct. He said that that particular set of shlokas which you are quoting were shown to be prakshipta, that is put in afterwards. And by whom were they put in? By an employee of the East India Company. And he had used the company's rules. That is why the company rules we are using today ourselves. So he was using those rules. He put them in good Sanskrit, and because they are in Sanskrit, you automatically assume that they are correct, they are old. So you have to be careful. That is the point that I want to make. So what I would certainly would like to compare between India and Europe is the following, that how were they treating people who were not not conforming to the general wisdom, but who were going independent way, like Aryabhatta or Copernicus. You find that Aryabhatta's life does not contain any information about whether he was mistreated or whether he was put to any problem. Copernicus was certainly put to a lot of pressure. So we know this difference in the way these people were treated. So now there is another example I want to give. This was a French, what you call observer, French observer called Le Gentil, who was a French astronomer in Paris. And it was known to the astronomers that there would be transit of Venus when the Venus goes across the solar disk, which is an observation many astronomers wanted to make. So the idea was to send somebody to India to make these observations, because people felt the closer you are to the equator, the better is the overall result. So when Le Gentil was chosen by the French Academy of Sciences to go to India and do this observation, he properly allowed how long it will take to go to India and do the observation. This was about 17th century, 17th or something like that, long back. So you had to go by a conventional route, by surface, and then go by boat for a certain distance. It was not a question of modern astronomers who jet fly somewhere, make observations and come back, and then reduce the data. It involved going by a very long circuitous route. And to make matters worse, there was the Anglo-French, 7 years war going on. And therefore, certain parts of the highway to the east were not usable because it was dangerous to go there. So he had to go into a circuitous route. So by the time he reached India and to Pondicherry, because he was a French person, so he needed a French place in India, to Pondicherry. He went there. By the time he reached there, it was too late. The Venus transit had already taken place. So he said, according to the theory and information, another a few years, 7, 8 years later, there will be a second transit. So he said, I will wait for that period and do the observation second time. And in the meantime, to keep, he won't just hang around, do something. So he had a good data on various observations to be done from that region. He did that, and when the second transit came, it was unfortunately clouded over and nothing could be seen. And being French, of course, he wanted to know what the British did. And he was quite pleased when they said we couldn't observe because over Madras also. They observed from Madras as he observed from Pondicherry. Sky was not observable in that. So the result was that Lejontil, the original work could not be done. He did a lot of side work, which I have mentioned. Then he came back. On the way back, he was shipwrecked. And once I think he was, some pirates also were involved at some stage. So he was delayed a lot going back. And by the time he reached Paris, people had thought that he was dead. In fact, he was legally declared dead, and his property was divided amongst his whoever had been entitled to his successor. So he went back, and the French judicial system must be quite good because he finally managed to get all the money, all the property that had been given to others. They returned it when it was known to be alive. And to make the story finish happily, he got married to a good lady who was very helpful to her in observations. Now, the question that I want to ask after all this story, this thing that Lejontil went through, the question that I want to ask is, look, this Frenchman came all the way from Paris, detours and all that, apart from the regular route. He did this. The English astronomers, whoever they were, they also traveled so much to do this observation. Why don't we know of any Indian astronomer who felt we should go and see transit of Venus? If these people are coming from such a long distance and doing it, why didn't our people do it? And I don't know the answer, why nobody was interested enough to do this thing. But this is one example of kind of deterioration had set in after Aryabhata and Bhaskara, when the astronomy interests were supreme and a lot of interesting work was being done, that had somehow gone astray afterwards. Then I want to, again, just to illustrate how this success, how the scientific results are treated by people and the scientists themselves. I want to give you the example of Newton. Newton is supposed to have done most of his very important work in the 1660s. So from 65 to 67 or something like that, 64 to 66, in which he derived the law of gravitation and showed by calculus, which he himself invented, how to work out the orbits of planets and show them to be similar to what Kepler had empirically found. So this was all done by him in the 60s. But he did not publish it. And after around 1984 or so, when he started writing his Principia, at that time he made all these announcements. Earlier a bit, he announced whatever his discoveries are, and that got him into problems like Hooke saying that he had got the law of gravitation first and Newton had copied it. Well, whatever the reason, that controversy went on, but the fact remains that Newton had the ability, calculus-wise, to do this calculation, which Hooke certainly did not have. So when Newton was asked by Halley, like the famous Halley's comet, you know, the person who observed it. So when Halley was invited to Newton, he was a good friend of Newton's. So when he was going to see Newton, some people in London asked Halley to find out from Newton when did he do this calculation of plan. Does he know the answer? So Newton said, of course I know the answer. The orbits are ellipses according to Newton. I had proved it. So he said, can we have a look at the proof? Because there was always the danger that if you ask Newton proof for something that we are not trusting him, he would be very annoyed. So Halley very tactfully asked him, can I see the proof? So he said, yes, I will give it to you. He went to his room, inside room. And after some time, he came back saying that he doesn't see, he seems to have mislaid the paper in which he had done, so he will re-derive it. And he re-derived it and gave it to Halley. Now the question was, why did he wait for 20 years to publish? So Newton said he wanted to prove, wanted satisfaction on two aspects. One was that when you take the force of attraction, you say it is square of inverse square law, the distance between 2 points into attracting bodies should be r, then 1 over r square. The question was, if you have a spherical body, like a planet or the sun, how do you know that the total effect is the same as at the center of the body, as if the whole mass is at the center? Now, if today you can do this problem using integral calculus, people if they are bright enough at 12th standard, they can do it. If they are reading their calculus in the first year of the graduation, they can do it on that basis. So when this was done, it could be shown that a spherical body attracts as if the whole mass was centered at the point. Newton took several years to prove this for the first time. And then only he was satisfied that he could go ahead. Another thing he wanted to check was the tables of astronomical observation showing how the moon goes around, what are the variations in the year. So this was observational point. So what I find very interesting here is that this was a very important fundamental discovery, but Newton was willing to wait for 15, 20 years before he could be satisfied that everything is right. In modern times, what would he have done? He would have, even before satisfying himself, he would have called a press conference and announced this. And then people would have started saying who should get Nobel Prizes, Hooke should get or Newton should get. So this kind of attitude that we are dealing with has changed a lot in terms of research. So you can ask, what would have happened if Newton, Fermat, or Lagrange were doing their research today? So if Fermat's last theorem he had sent for publication, so the editor would have said, you sent it back, and you either say yes or no. Why? You can't publish something which is not published, conclusive. So anyway, just to show how things are different. So now I want to come to the question which I said that I will come to the end, I will come back to this point. We have in the 21st century, the question now, we have a scientific establishment which is very broad and very big. Does it now have its own rules compared to Copernicus and Galileo, who were put to a lot of problems by people who did not believe in certain results which were proved correctly? So, so the answer to normally we give is, yes, science today is very pragmatic and it gives you okay only if a number of sort of experts agree on what you have proved. So it is what I would say is well established and fair. On the other hand, there are cases where there are still modern Copernicus and Galileos around. And I will give you the example of Halton Arp, that is an astronomer who died about 10, 12 years ago, but he had done extremely interesting work, and his atlas of galaxies is taken quite seriously by astronomical community for giving details of the universe around us. But after that, around 1970 onwards, ARP began to find data which was difficult to to explain in terms of Hubble's law, which says that the universe expands in a certain way. So the expanding universe hypothesis was not being followed according to ARP for a number of observations. So he had a lot of problems to publish this work. In some cases, the referees would toss him around saying, we can't agree, let somebody else examine it, to go to the somebody else, that somebody else would say another somebody else. Sometimes the paper was hanging fire for 9 to 10 months, and then ultimately it might be rejected. So ARP was feeling that this was like the treatment Copernicus and Galileo got. The worst situation occurred because he, in the following sense, he was a reputed permanent member of Mount Wilson and Palomar observatories. And he used to, that had the biggest telescope at that time, to 200-inch telescope. And that particular observation, a particular observatory, ARP had entitled nights to observe, a certain number of nights he could observe. But then one day he got a notice from the committee which controls the nights, saying that we regret that we cannot give you any further nights on this telescope. Why? Because you are producing results which don't make sense. That means you are producing results which your present theory cannot explain. So that doesn't mean it doesn't make sense necessarily. So ARP had to leave United States and go to Germany, to the Max Planck Institute, where he served for some years. There he got some observing nights in telescopes which were run by the Europeans. There were problems, but he could at least get something. So this kind of effect shows you that if you find some result which doesn't fit in with your existing knowledge, you should have the openness to do an alternative study, to test it. You shouldn't draw a conclusion immediately that it must be wrong. So what I would say is that in the case of ARP, the problem was, in a sense, the same problem, mitigated perhaps, but similar to Copernicus and Galileo. Finally, I want to tell you one story which Chandrasekhar, in his interview, which I was part of, asking him questions and so on. In that interview, he said that when the Mount Palomar telescope was under construction, when it was approved for construction, this was the 200-inch telescope. This was approved for construction in the 1930s. And then it was delayed because of World War. But then it was finished, and then it was starting good work. But while it was just approved for making, there was a press conference given by Eddington and Hubble. Eddington was the theoretical cosmologist, and Hubble was the observational cosmologist who had found the law named after him. So they were asked that this telescope that you are going to build, what will it show? What will it find? So he said that if we knew what it was going to find, then what was the purpose of building the telescope? So what they were saying is that they were keeping an open mind, and they don't want to commit themselves that this is what should happen. But precisely the opposite happens today. If you want to propose a good super telescope, you are asked by the committee to say what are you expecting to find with it, and how do you want to show it, and etc. In other words, you are assuming that whatever is being found is already consistent with what people believe. There is no sign of a possibility of openness here. So when one talks of culture of science, I feel that this openness is very important, and we should make sure that our societies keep to the openness, which is the main strength of science, and I hope this will happen. Thank you for your patience.
Mr. Narlikar, what you said just now reminded me of something else. 2 or 3 hours ago, I was looking up something on Fred Hoyle. I hadn't known that he'd passed away, but I discovered that during the Second World War, between 1940 and 45, he'd worked on radar. and how to counter the radar-controlled guns on a ship called a German warship. So I was reminded of a recent incident a few months ago where an honorable Indian gentleman said that cloud cover was enough to counter radar. Would you like to comment on that? On that kind of scientific attitude?
Can I could not get the thing.
Repeat that?
I think you can come and sit here and do the translation. What I would suggest is if she sits here, she can translate. See, sometimes because of my hearing impediment, I don't hear the question correctly and answer the wrong question. and some people think that I answer only those questions which I hear, or hear only those questions which I answer. Yes, but we will try. Mm-hmm.
Text was that
Well, I don't have the details with me, but it is true that Fred Hoyle worked in the wartime in radar system, which was fairly new at that time. So issues like what you said must have arisen at that time, but I don't know how they were dealt with.
Excuse me, I have one question with dealing with quantum mechanics. It is about electricity. Electricity, we all know that is made up of electrons, but electricity is an energy and electrons do have mass. How is this possible?
electricity is made of
Well, I think what you have to see is that electric current, let us say, means it is current, means charges are moving, electric charges are moving. So these may be electrons because they are the lighter charges. So when electrons move, the current is established. The question is how fast they will move. That would depend on their mass and how much force is allowed to move them. So this information has to be used, but there is no conflict with the idea that charges are masses. In fact, charges will have mass, and when they move, they will produce currents.
Thank you.
So, with my limited knowledge, this question may seem, I can't find the word for it, but I would like to ask anyway. They say that matter cannot be created nor destroyed, right? So, so because of the Big Bang, like everything came to be, right? So how is that matter there initially itself? Like how is that matter just there? Like how did that come to exist? There has to be a creation point, right?
You are asking that if matter cannot be created out of nothing, how was the universe created?
Yes, sir.
Yeah. Well, I don't particularly subscribe to this idea of how the universe was created. So I will ask the same question as you are asking. but I will ask it to somebody who believes in that theory. So
Yes.
the answer is you are supposed to ask this question about how is matter created uh, only after the creation has happened, not before. So,
I got it, sir.
the zone of applicability is
Yeah.
after creation.
But
Now, why you should have a creation event in the first place, nobody knows.
so can I? So, but how did they come to the conclusion that matter can't be created or destroyed? How did they?
Well, the law of conservation of matter and energy has been generally assumed as true in terms of the basic physics that we know and the observations in the laboratory that have been done. So far, it seems to agree. But whether some extraordinary circumstances it occur to violate this, we don't know yet.
Thank you, sir.
Sir, I would like to know your thoughts on how far have we come towards the unified theory of gravity. Because Stephen Hawking, in his book, actually propounds that there can be one unified theory of gravity, where quantum mechanics and the theory of relativity can be combined to come to a unified theory of gravity. I just want to know your thoughts about that.
Well,
What is the progress?
the unified theory was the goal which Einstein was following. His idea was unifying electromagnetic theory with gravity. Now, modern ideas on theoretical physics give priority to the other end, that is, gravity comes at the end, and first you try to know how matter, how the other three basic interactions, strong, weak, and electromagnetic, they combine together, unify, and then they will also bring gravity. This is the alternative view which is at the moment guiding more people. But still, it is anybody's game. If they can produce something viable, it is worth trying.
Sir, in your 2008 book, Facts and Speculations on Cosmology, you talked a lot about how academia had a rather closed mind to your theory, which was the quasi-steady-state cosmology theory, and how academia favored heavily the Big Bang theory. Now, it's been a decade since that book was published. How has academia's open or closed-mindedness changed since then?
Okay, the quasi-steady-state theory was suggested, proposed by three of us. That was Fred Hoyle, Jeffrey Burbidge, and myself, in which we used some ideas of the old steady-state theory with some ideas of conventional cosmology. And that together we came across a model which seems to do everything right in terms of the present day observations. So for example, you have the universe as oscillating and then also long-term steady expansion. So this kind of thing, I give the analogy of vegetable prices. During the year, the prices go up and down, but they come back to original point. But if you examine after a few years, the vegetable prices have gone up. So there is a long-term expansion, long-term uh, increase in the prices. So same way, the universe oscillates over short term and expands continuously over long term. And that produces the right kind of conditions to explain microwave background or light nuclei and various other problems which the old steady state theory could not do.
Yeah, so my question was, how has academia changed in response to this theory? Because in your book, you describe a lot about how academia favors the Big Bang theory and has suppressed this theory to a large extent. That was a decade ago, so I want to know how academia has received your theory in the last 10 years.
Quasi-steady.
How is it received today is my question.
You see, it is not received with great deal of enthusiasm. This is putting it in a very mild way. The thing is, at the moment, people have a certain framework of how the model works, and that framework requires certain assumptions. These are extra assumptions which are taken for granted but not proven. So that is preferred over the quasi-steady state idea. One can discuss details later, but if you are interested in a non-technical description, I would suggest you read our book by Burbidge and myself, called Facts and Speculations in Cosmology.
Yeah, I've read it. That's what the question was based on, actually. Yeah, thank you.
Hello. Good evening, sir. You stated that Chinese observed the explosion of a star. Was it visible to the naked eye, or did they use a special tool to observe it?
Yeah, I told you the example of Crab Nebula.
Yes, sir. Naked eye.
Was it visible in detail?
See, the Crab Nebula explosion, was it visible by naked eye? That at the time it was, when it happened. And it was even possible to see it in the daytime.
Thank you.
Why is that? Excuse me. Usually, people will expect scientists will have almost every scientist should have scientific temper. But in India, I think scientists with scientific temper is relatively less compared to the other developed countries. Why is that, or why Indian scientists are not having that scientific temper?
Well, scientific temper is a concept which is still to catch on in the Indian scenario. You talk to people, some are, you find, aware of it, and others are without it, and they don't care whether they have a scientific temper or not, because...
He's talking about the scientists.
Sorry?
He's talking about the Indian scientists.
Well, whatever I said about general population, same thing happens about scientists. I don't think scientists have also that, maybe the fraction of scientifically tempered scientists is more than normal citizens, but there are still quite a few of them who don't have it.
Hi, in my understanding, around 500 to 1,000 years back, the major factor driving scientific progress was religion. In my understanding, 500 to 1,000 years back, the major factor driving scientific progress was religion. over the past 100 years, the major factor driving scientific progress has been war. In your opinion, what's going to be the factor that will drive progress of science in the coming 100 years?
What will be the driving factor for scientific progress in the next 100 years? Well, I think usually two things serve to progress science faster. One is genuine questions about basic science, which have still yet need been answered. So people would want to do more and more work on that. And the second is the expected progress in living standard that you would like science to provide. And for that, some applied research has to go on very rapidly. That is.
Sir, my question is that why is quantum gravity is not fully established today? I mean, what is a factor that is making it too difficult to formulate a complete compact theory on quantum gravity? Like, for example, quantum electrodynamics. We have a theory for that. Why aren't we able to quantize the gravity?
Why don't we have a quantum theory of gravity yet? Which people are trying, but the question is not so simple. So I don't think one can put a kind of big why question mark. Why means I can only answer there are several basic issues involved which have not been sorted out. So until we understand those, we may not get a satisfactory theory. But different people have different perceptions, so I would not say that there is a definite answer to that particular question.
Thank you, Professor. Good evening, Professor. Yeah. My question to you is, it's regarding the open-mindedness in science, which I think is the crux of your lecture today. My question to you is, and also you answered something about scientific temperament. So my question is, do you think there is something that can be done in our basic and higher education so that we can bring about a temperamental change in open-mindedness and scientific temperament of our country?
I think we should encourage children, school children, to ask questions. And my suggestion has always been that in every standard, during the 1 week classes, I mean, you can ask in each school, per day 7 classes are held, let's assume. Then in the week, you can say 35, 40 classes are there. One class out of these should be open for children to ask questions. And the teacher should try to answer or try to encourage them to find the answer. If this happens, then they will not only find science more attractive, but also they will learn to ask questions. My feeling.
Thank you.
My question is, so talking about the culture of science, we see that these days a lot of politicians and public servants are making a lot of outlandish comments regarding India's past and a lot of other unscientific stuff. So do you think that the Indian scientific community is doing enough to arrest those tendencies? And if yes, then why is the Indian scientific community giving platform to such ideologies, especially, let's say, the Indian Science Congress? We hear a lot that these days, such forums are, kind of giving platform to others, a lot of people with such ideologies to spread their propaganda. So what do you think about it? Or what can we do to stop such tendencies?
I think there is awareness in the Indian scientific community that something has to be done, but I don't think the community as a whole has one view. They may have different solutions to offer.
Okay.
But the problem is there, I admit.
To ask one question, maybe you should give the last chance to the next person, and we'll stop here.
Hello, sir. My question is, even in our modern society, there's a great belief in astrology, and they claim to be it an exact science and base it on the position of planets, and they, they substantiate their claims of whatever their beliefs on astrology are using that. So what is your view on this as an astronomer?
The astrology has to be shown to the common man to possess no predictive power that is normally claimed. And this is something which requires a lot of tact. It is not that simply my telling somebody that you are a person believing in astrology, which is all bunkum. I have to convince the person. And that is not going to be very easy, but attempts should be made. That's my feeling.
Like all good things, this also has to end today. So let us all thank Professor Narlikar for this wonderful lecture and interaction.